Okay, this question is a little bit wordy. A survey at a sixth form college which has 512 studying a certain course to determine whether they pass the examination or not. Students were asked if they revised or not for the examination, and the results are shown in the table below. This is called a two-way table. So we've got here the people passed, not passed, okay? So these are the people passed and revised and did not pass. That gives me 265. And here we get passed an exam and not revised. Here we get not passed and not revised. If you add these all up, they all add up to 512, which is like the universal set. So a student is selected at random. Find the probability that he revised for the examination, did not pass the examination, revised and passed the examination, did pass the examination given that they revised, did pass the examination given that they did not revise. So we're going to look at this with like formal notation. So here is our two-way table. So let P be the event the student passes the student actually passes the exam, and R be the event that a student revises. In part A, we want the probability that a student revised for the exam. So probability of revising, so the probability of R. So the probability of revising for the exam is given by this one here. So it's a number in R divided by the number in the universal set. So this is a number in R. The number in the universal set is 512. So that will be 265 divided by 512. B, the probability that a student did not pass the examination. So the probability that the student did not pass the examination is the probability of not P. That's a number in not P divided by the number in the universal set. So the number who did not pass the exam is 240. The number in the universal set is 512. So it's 240 out of 512. And if you can cancel down, you should write down the cancelled down value, which is 15 out of 32. Part C, you want the probability of a student revises and passes the examination. So a student who revises and passes the examination is the probability of R and P. So the probability of R and P divided by the number in the universal set. So R and P is 183. The number in the universal set is 512. That doesn't cancel down. Now part D, we want the probability that a student did pass the examination given that they revised. Right, so this is conditional probability. So the probability a student did pass the examination given that they revised. So that's given by the probability of P given R, which from the formula is the probability of P and R divided by the probability in R. That's given by the number in P and R divided by the number in the universal set, divided by the number in R divided by the universal set. So P and R is this one here, 183. That will be out of 512. And revised will be this one here, which is 512, which will give you 183 out of 265. And you could have got the answer straight away by doing 183 divided by 265, but I just want to show you how the formula works. And the probability that a student passes the examination given that they did not revise. Right, so that's going to be the probability of passing given they did not revise. So it's P given not R, which is the probability of P and not R divided by the probability of not R. So the probability, this using the formula, which would be the number in P and not R divided by the number in the universal set, divided by the number in not R divided by the universal set. So that's going to be 89. These did not revise but passed. That's 89 out of 512 divided by 247 divided by 512. The 512 cancel out, we get 89 out of 247. So again, you could have got the answer taking that one, dividing it by this one. This just shows how the formulae work. Now, Note, because the probability of P and R is equal to 183 over 265, and the probability of P given not R is 89 out of 247, does R have an effect on the probability? Yes. The fact that they revised or did not revise does have an effect. So these events are not independent. For these to be independent, these two values would have to be equal to each other. They are dependent on each other, i.e. revising is more likely to result in passing the examination. Now, there is a different way of actually representing this table, and it could be done by using this Venn diagram. So you have a universal set, and here you have one of the items. So revising is 265, so revising is 265, not revising is 247. Okay, and here we have the probability whether they passed or not passed. These are the ones that passed, these are the ones that did not pass. Okay, and here so we have 82, and here we have 158. So those come from these numbers here. 82 will be not passed and revised, and the 156 will be the ones that did not pass and not revised. Sorry, the 82 will be the ones not passed and revised. Okay, you can look at it like that. For me, I think it makes it a little bit more difficult, but it might help you to be able to represent it like that. Depends how you see the idea. Okay, this has been a video to show you how to use two-way tables on conditional probability. I hope you understand, and I thank you very much for watching.